Yeah, but we wanted it to be second nature, so that's why we're doing it.
Man, I am not right.
I mean, after these 5, we're just gonna need to do it for.
4 is H2,
Oh.
SO3. Goes into H2,
We
SO3.
like
No, it goes into H plus.
H plus is not plus.
Hold it, are you the same? Or?
Yeah.
Well, that's 4 and 5. I thought you said 3 and 4.
HS.
Oh, pardon?
How do you do the charges
If it loses a hydrogen, the charge goes down. If it gains a hydrogen, the charge has to go up. So if it's HSO3 and it loses a hydrogen, and H plus, then it would be SO3 minus 2. Minus 2.
meant to be like
Because it was HSO3 minus.
Oh.
So it was minus 1, you take away a hydrogen, now it's minus 2. The other way to see it is that whole side is minus 1.
Minus 2. Oh, no.
Minus 1. So this whole side is now minus 1 as well. Charges should also balance, because that's plus, yeah. So that's a quick way of checking your work.
Oh, that's it. Just 4.
And plus the KQ, it would be squared.
The two
If there was a 2 here, then you would say this. But it's just
Where?
I think, right?
Oh, hold it. Oh, you just eventually stopped writing KA equals.
Oh.
Lazy pause. But you didn't put H2 only where the ratio is correct.
Solids are always
No
no
KA
H2O.
equals your 3.
He didn't say with water.
Oh, yeah.
To be fair, he
Oh.
did not say with water.
Alright, good job.
KA equals. Oh, yeah, it's working.
He did not say with water.
There you go. Yeah, put H3 minus here.
He said water here. So get that out.
Word.
No, it says water.
Appreciate you.
Oh, and I forgot to do attendance. That's what I was supposed to do. Where is it? Where is it? While they're finishing up. Get that going. Very quickly, Etienne, Lavina, Theo. Does he? Yeah, I saw Theo. Samuel, Ella, Sonia, Andrew. Yes, he is. Nathan. There we go. Katie, Nicholas, Paz, Gleb, Max, Ashley, Nika. We're all here. Excellent. Which means we should have an even number of people. into new groups. New groups.
Wait, I wanna write this down first.
Yeah.
You want to write it down first?
What's up?
Yeah.
Or just leave it blank and save it for later as extra study.
No.
Oh,
What do you think you are?
You mean, did I figure out a way to make you write it twice?
Yes.
Smart man. And I did attend it. I think I missed someone. 1, 2, 3, 4. Because we don't have that one. We have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Aha! Missing person. Oh, I thought you had a note.
No, I
You
just
just
thought
have
my,
your head in your pocket.
yeah.
Why is it late?
All my classes in Crooks and I was already late for that, and then it was not.
Your class was late. Oh, you thought
Yeah,
your
I thought I
class.
had math class first.
Okay. Take a look. We just did KAs for everything. You're about to get practice doing KBs for everything. That explained my miscount. So quiet. Has everybody done these ones? Hey. There's 7. Good? Any objections if I move? Next. Okay. Let's. Grab your partner. Erase the old part of a board. Get ready for the And then it's just the next page, you're doing KBs. Josh and Sam, does it always put you together?
Nah,
As far as I can tell, every time I've noticed.
we just we just go beside each other. Make our way.
Because it did that the last day, didn't it?
Yeah.
Yeah.
Again. KB.
Hey, did you pass it back with your book?
Are we doing? It's literally the exact same thing. I know, but we just have to work on that.
So yeah, you're doing the KBs. The base equation for each base.
What is this first one?
It's the exact same as said you take away the H from the water.
I'll start with.
Remember, when you're doing these ones, you have to be a lot more careful than the other ones. They're quite a bit more dangerous
Yeah, just
because you don't want to
Mine was just
drop
like
the
supposed to
base.
be.
IO3 is the asymptotic negative one.
Yeah, so then it makes
It's LH, yeah. Well, you know.
Now, a couple of general reminders. Hold it. Number one, don't forget your charges. Gleb, you've committed the unforgivable sin. You literally dropped the base.
What?
You're not writing base equation.
Add H2O, not
You're adding acid into the water.
Nah, you're right, you're right.
That is what it would do in acid.
That's easy.
Because it's aqueous, and you always have to. So, for example, Haiti, when these ones are up, oh, it's not a touch screen anymore. Here, I don't think I mentioned this. For some of these, I added water, and some of these I didn't. Why would I do it for one and not the other?
No, H2O is like the liquid.
Yeah. So the answer is it's arbitrary. For acids, this is the true reaction. You make H3O plus. And this is just a simplification. But because we're giving off H, you can make that simplification. It's not a problem. You don't have to involve water if you don't want to. You can pretend it's not there. Would it be wrong if you didn't add water? No, because number one, I did. And then you just get H3O plus. No, HF plus H2O goes to H3O plus F minus is exactly the same reaction. Just a simplified version of it. But for these, you can't make hydroxide without taking it off of the water. So the reason Bronson-Lowry bases are bases is because they create hydroxide by accepting their protons from water. So you have to involve water in these. So fast. Anybody else do that? No. They're all making hydroxide. They're all making hydroxide.
So you took the H from here, so now you have plus one.
Yep.
Smart screen.
The charges are looking good. And
I would not. You're gonna like walk through caves or fucking.
there would be students who could afford a golf cart and would try to bring it.
Carter Pierce.
They what?
Really?
Really? We should have torches, lit torches around campus. Like the open flame, or, you know. Yeah. That'd be
Yeah.
Okay, well, that's taking Interhouse a little too far. These are from the last one. Nobody does this. Okay.
We have a perfect view of the
That's so true.
The view of the boarding building. Yeah, but the other side of the
yeah.
You have like an
I'd
ocean,
rather, I would
like
like
the
watch
ocean.
people, like people in like the top floor of math like wake up to like wake up to sea. That's the only spot.
I would wake up to no heating.
I wake up to like
There is no heat.
Where's
The heaters don't work. Like, they're just not even connected to
Bro, my heaters work too well. It's a freaking sauna in mine.
Bro, me and Cole
Fuck, I wake up also with heat and shit out there. I got so bad.
Like, it was like negative and shit. My water
Language.
bottle was at my bed.
Josh.
I mean, shoot. When it's cold and stuff. You know, there's no cheating in me and Cole's room when it got to like negative temperatures at Christmas time. I'd wake up, my water bottle beside my bed would be frozen. That's how cold it was in normal.
What is your house brand do?
We told him like 10 times. He's like, I got a work order in, and no one ever came.
The heating systems in all those houses are messed up. I put in tons. What I suspect they're going to do once we're out of here is that they're going to tear this building down and build a new house, and then we'll start replacing Privet Metal and Ellis.
So just said because that was the thing wrong, so they're taking Woodward down and building like a huge gas station.
Yeah, because then they can
Like a
build the
girl's
house
size
and then
for Alice.
move it over.
Well, there's only like 3.
Well, and
Kaz
there's
gonna
only
move.
two
I have
floors.
a
You have
tiny
to
little-
on duty walk like it seems like to the sky. And check on anybody. You have someone on duty at every floor.
No.
Yes, we know.
Yeah, Mac is like the most chill.
Duty last night was so nice. So
Oh right, how many floors is Mac?
4.
That's crazy.
Being a top us on Mac would be
How do you like a little Fairmont just in the middle?
Bro, you should see my room.
Don't be chatting to me about it's so tiny. There's a grade 9 with a bigger room. There's grade 11.
Okay, that's dope.
It's a grade 9, bro.
He's a poor little boy. He
Sorry.
needs a big room. Poor guy. Okay. For base reactions, you do have to add water to all of them. Why do we have to add water to all of the reactions?
Because water can be an acid, it can react as an acid or a base.
Right. So, but why do we need to for KBs? Because if we go back and you take a look at what we did for the KAs, I didn't add water to all of them.
Yeah, but you can, right?
You can. You can. So I did HiO3 plus H2O goes to IO3 minus plus H3O plus. I didn't do it here. But I could go HF plus H2O goes to H3O plus F minus. In an acid, you don't have to because an acid is a proton donor, and we've accepted H plus as a shorthand for H3O plus. And so you could have written all of these without putting in water. It's a shorthand, it's simplified, it's not quite as correct as putting it in, but everybody accepts it. Whereas for a base, a Bronston-Lowry base doesn't give anything away, it accepts a proton. So it must have something to accept it from. So you need water in there, and so it can accept it from it so you can create hydroxide. Bronston-Lowry bases are bases because they create hydroxide by accepting a proton to water, even if they're just by themselves and not with anything else. The equations and reactions that you read will never say this is in water. If it's aqueous and it's an acid or a base, it has to be in water. It can't be an acid or a base or unless it's in water.
Mr.
Yep.
For the base ones, for the KB, do we write the H2O?
No, why not?
Wait.
Did you write the H2O in yours?
You wrote H2O too. You wrote IO3
In the KB equations?
Yeah.
Oh, no.
Why are you confusing me, Andrew?
Andrew, why don't you write it in the equation?
Because it's a liquid.
There you go.
So you don't write it for KA and KB, just because it's a liquid?
You don't write it for the KA or the KB, there's no H2O. You didn't write it
You don't write
in the
it.
previous one.
Oh,
Because remember when we did KQs, we didn't put solids in?
yeah.
We also didn't put liquids in.
No.
That was a rarer of a case, but yeah.
And if there's H2O on both sides, we have to write it down.
In an acid-base equation, there won't be H2O on both sides. However, if you ever have a KQ where there's a liquid on both sides, then you have to put them both in. But even in that, there wouldn't be water on both sides
No, okay.
because it would cancel out. That would then be water acting as a catalyst, and it would cancel out of the overall reaction. But yeah, if you had a pure liquid on both sides, or the reaction was all liquids, so like it was a reaction of oil and ethanol and acetone. Oh, it's not touch.
What happened to the touch screen?
Mr. Hacker Temper is using it. It's the only mobile screen, so if someone in the lab wants it, they get it. Sadness.
Give you like 2 more minutes.
Hmm?
Give you like 2 more minutes on that screen.
Can I what?
You have 2 more minutes on that screen.
No, sure. You're still writing it down. And while you're waiting, if you are waiting, please get out your data table. Okay, Ella, put away your phone, please. Way in your bag. Put it away. Anybody still ready? That needs this up?
No, I'm good.
You good? Okay. Next one is just relating Ka and Kb to the strength of the acid or the base. When we look at our data table, how are all of the equations written? Are these acid equations or base equations? Acid. And to make the table nice and small, they're written in the simplified form, so it's not plus H2O, it just goes to H plus the base. The Ka is given on the right, and you can see the strongest acids are at the top, Now, if it goes over 100% and there's none of this, then you have products over zero reactants, so you get a Ka that's either undefined or infinity, depending on how you want to interpret that. But if you have any of these other ones, you can use their Kas. You also secretly have the Kbs because they're inverse to this. So the weak bases are on the top and their strong bases are at the bottom. You don't have a list of their values, but you can calculate them from that value. So we will be looking up the Ka on the table, but we're going to be doing the Kbs first. Oh, looks like I have to write something down. So stronger acids have larger Kas. Similarly, stronger bases have larger Kbs. The table does not have the Kb. We have to calculate it. And I want you to ignore this for a second. Don't cross it out. Just ignore it. I would like you to write the Ka for the generic acid HA. Write out the equation first if you need to, but what would the Ka for that be?
Wait, K for what? Is it
HA.
Huh?
Oh, yeah.
HA. So HA goes to H plus A minus. What's the Ka? What's the equation?
H times A over HA.
Yeah, you've just been doing that. So we got H times A over, what'd you say?
HA.
HA. Excellent. Now, I would like, so that's the generic formula for any weak acid. Now I would like you to write the same formula for the Kb for the generic weak base A minus. So Kb would equal, I'm going to do that in a different color to make it obvious. Kb would equal what? Someone else. You already answered it. Glenn?
It'd be HA times OH minus over A minus.
Yeah. Because we have H minus, H2O, OH minus, HA. Excellent. So we have two equations that we can get for any acid or a base. What relationship do you already know from previous where Kw equals what? What times what?
1 times 10 to the negative 14.
No, not the number. What two values multiplied together?
Ka times Kb.
No. I mean, maybe. I said previously taught. Like, that. This is you've only seen today. I have previously given you an equation with Kw. You have used it to calculate results.
No, just
Tess and Gleb, what are you doing to poor Andrew?
Oh, nothing. Just making
What equation, what mathematical relationship have we already done with KW?
Wait, would it just be like the two fractions multiplied by each other?
I'm going to do something with that in a moment. But first I want to put together, you've used this just last day.
I don't remember what happened, but it was.
Turn back a page or two.
Listen like the last minute?
Nope, in this unit.
KW.
Or maybe, hold it. Yeah, it might have been the last unit. In the previous unit, you used this several times.
Oh, H plus times OH minus.
Yeah. I would like you to take this equation, that Ka1, and rearrange it so it's concentration of H plus equals algebraically. So take this, take the A minus HA, put it on the other side with the Ka.
Wait, can you say that again?
Take this equation and just make it H plus equals, solve for H plus. Take all these things and put them on the other side. What would you then get? It's going to be a very math day, and I'm really hoping we get to the section that makes every math teacher upset. It's worse than sig figs. Yes.
HA minus A minus.
HA minus?
Or wait, divided by.
HA divided by,
Wait, never mind. I heard A minus, but I think that's what.
hold it, where does A minus go?
I don't know.
No, I think we're on the right track, but anyway, okay, we gotta start. Also, if I say, what did you say, or pardon, I'm not implying that you're wrong. I have allergies and I literally can't hear right now.
It goes on the bottom.
A minus goes in the bottom. What else are we missing from this?
Ka.
Okay, where does it go? Top or bottom? Top. Hey, so we're just rearranging it algebraically. Do the same thing for Kb and make it hydroxide equals. What would this equation be if it was yes.
KB times A divided by HA.
Excellent. Now I'd like you to take both of these, substitute the H plus for that H plus, and substitute the OH minus into there. And then when that all settles out, tell me what you get in the simplest form. Take you've done what H plus equals, so you know it equals that. Substitute that in there. You know that OH minus equals that. Substitute that in there. Do what you need to do to give it to me in the simplest form and tell me what you get.
The Ka times Kb
Yeah.
is Kw.
So you've just derived that formula. You take the H plus, you end up with you take the other one, and everything ends up canceling out. So the original equation I started with, KW, and I said, ignore that for a second. I wanted you to know where that came from. It's not just arbitrary that it works out like that. It's because they're conjugates that everything can cancel in that way. And so that gives you a very quick way of calculating Ka and Kb. So if you have the Ka of something as our table does, then you can very quickly calculate the Kb. Because at 25 degrees Celsius, what does Kw equal?
5.0 times and negative 44.
Yeah. I always love that they say 25. They only pick that temperature in order to make it. Otherwise, it'd be a decimal there. Standard temperature and pressure is 0 degrees Celsius. Room temperature and pressure, I believe, is 20. And then for this one, they just arbitrarily say 25 to make the calculation easier. And as a rough estimate, it's close enough. Good. Not going to make you go up in groups unless you really want to. Do these on the board or do them where you are. Where you are. Calculate the Kb of F minus 1. Calculate the Kb of HCO3 minus 1. So look at the table. Use that formula that you just derived. And then I am going to ask some people at random. Get up my app.
Could you go back up to the page quickly?
Pardon?
Could you go back up to the page for a second?
For that?
Yeah, no, just up top right now. Yeah.
The very top?
Can you go back to
Good.
just down there?
Okay, F minus 1. Do the calculation after. First, I just want what you calculated, and we'll compare with the class. First one says Taz, what do you get for the KB?
Sorry?
What do you get? First one, what do you get for the KB? Let's go. I'm going to wander over there. I think I may put everybody back at the whiteboards again. See what you're doing. What do you got? No, no. just got I'm looking for a number.
Oh, come on.
I think we made the same thing.
2.86.
Flip to the previous page, very quickly. Flip to the previous. You just spent a ton of effort coming up with it. What happens when you multiply those together? Cancel everything, pull it. You have A minus 1 on both sides of it. Or no, that's HA. But you have A minus over A minus.
How do I get that? Because I have KB, but I don't have KH.
But we solved for OH.
Okay, we have KW.
Oh, we need.
Yeah,
So
which is
this was
1
like
point, yeah,
K,
blah, blah,
oh,
blah,
this
and
equals-
then what to
Yeah,
what's
that
A
should be
plus
fine.
and A minus.
There you go.
Okay.
So then,
KA is we just have formula.
Exactly, but KB we have,
K.
I got OH minus times HF. Like, divided by that.
But it just has like
one of those should be equal.
Yeah.
So that's the
I don't know.
So the OH plus equals, is that HA there? Or am I, oh, HA over A. This is HA times OH minus, but for the numerator, this gives you A minus.
It's like basic algebra.
So,
But I don't know
Zero.
like what KB is.
we get the KA from.
Because I did it here,
Yeah, I have that.
right? But
I
like,
like
how did that?
If I did like these for both of them.
Yeah, same.
But
Because one of those, Taz, you have the algebra in there. I can't see it when I'm looking upside down, but your two results. That should be your KB, and that's your KA. Does that look the same as yours?
Yeah.
Okay. And then when you solve it, your H plus should look like this with HA on the top.
Yeah.
And then your OH minus should look with HA on the bottom.
Oh, right.
I think you had one of them reversed.
Yeah, I put HA on the top and then
Yep.
HA on the bottom.
And then the final relationship we have is KW equals KA times KB.
Right.
If we don't have to do all those OH and H plus steps.
You can just do.
No, now we know this relationship.
Do the table and.
Yeah, you just look it up in the table.
Oh.
Yeah. So if we have this, KB is equal to KW over KA, which is equal to 1.0 times 10 to the minus 14 over, Taz, on your table of polyatomic ions, not table, sorry, your acid base table, what is the Ka that we're looking for? Oops, here we go.
3.5 times 10 to the negative 4.
Excellent. Okay, now grab your calculator, tell me what that number is. So now we are using the relationship we just derived. But we don't have to go through that entire process again.
2.86
2.86
times 10 to the negative 15.
minus, I don't think minus 15.
That's what I don't have it. Minus 11?
But is it 2.9? You got minus 15 in yours?
Yeah.
I'm gonna come over there and check. Did everybody else get 2.9?
It's 2.86, but if you round up.
Yeah, it's only 2 sig figs because of the thing. So, did anybody get a different number other than minus 15? Because you got minus 15 is probably how you're punching into your calculator. I can come around and just make sure you're doing it properly. Also, if you have times 10 to the minus 14 over 10 to the minus 4, using exponent rules, what is that number?
Oh, wait, yeah, no.
You got it now?
Yeah. 2 point,
What is-
it's still 2.9, but it's times 10 to the negative 11.
If you have 10 to the minus 14 over 10 to the minus 4, what does that equal? In your head.
10 minus
10 to the minus 10. So you can always do this, and then just make sure, is that close? It'll be a little off because it doesn't include these numbers. But you should get something close. Okay. Do that again for HCO3 minus 1. And I'm again just going to ask you for the number. I'll give everybody an extra 30 seconds. Is anybody here as beat? Are there beat reps in this room? No beat reps, that's it. Okay. Okay. Next person up. Gleb.
Yeah.
What amount did you get for this one?
2.3 times 10 to the negative
2.3, oops, times 10.
8. To the negative 8.
Did anybody get a different number for that one?
2.4 times 1.
Are you sure that nobody got a different number for that one? Yes? Times 10 to the negative 4? Excellent. How many of you haven't done it yet?
I'm doing it.
I will wait. We'll have a vote. All matters in science are decided by a democracy. We are awaiting the vote on the value of pi. We hope to make it exactly equal to 3 this year.
Yes.
It'd be fantastic.
Wouldn't that just destroy the idea of it being infinite?
Yeah, that would be great. Why does it have to be? We just made math up. Why don't we just change it?
Why do you get 2 votes?
Oh, you're right.
Big brain stuff.
You know, like space engineering.
When you're using Ka, would you use the one of the reactants or the one of the
Ah,
products?
that's a good question. Which one did you use?
I use the product.
Okay. I'm not saying you're wrong. I'm not saying Ashley's wrong. So I'm just curious how many did what. And I was really hoping I'd get 2 answers so I could address this point. I'm
It's
just not going to do
probably
it.
reactants, right? So I'd probably
What'd you do for F minus?
for F minus, well, there is no other one other aside from that. I
So,
used
so
so it is the reactant, the products.
there you go.
Uh,
How many got the first one?
so I got it.
Show of hands, please.
Because 1.7%.
First, 1, 2, 3, 4. How many got the second one?
I got the one.
Excellent. We've got now I can address this particular issue. KB is equal to 1.0 times 10 to the minus 14 over, and then we go here and we find HCO3 minus.
Near the bottom.
Down more.
It's near.
I think it's way down. Where is it here?
It's like
Yeah.
set one
It's
left.
here, and where else is it?
Top.
It's right there. So which one of these do we use?
The top one.
We use the top one.
Is the top one? Because this is, it says calculate the KB of this.
Okay.
So it means that you have.
When we did F minus,
This is the base. So you're not gonna.
where is F minus on here?
So before CO3 minus
Not a rhetorical question. You're pointing, but you're pointing vaguely at the board.
It's like at the top.
It's at, yeah. Is it on the right or the left? It's on the right. It's on this side. When you're calculating the KB, you have to use the one as it's on the base side because you're calculating a base. If you use this one, you're calculating the KB of this one. So that's the KB of CO3, the equivalent base. So that is the Ka of this acid. And if you divide that into 1.0 times 10 to the minus 14, you get the Kb of that base. So it always refers to the ones in the equation it's in. If you want the Kb, you have to find it on the base side. Go base side. Oh, and what was that again? On the base side, it was 4.3 times 10 to the minus 7. I ran out of room. Minus 14, minus 7. I'm going to assume that's the 2.3 one. Now, the reason that question is there is because I wanted some of you to do that because it's so common. You're just looking through the table, you find your molecule, and you're like, aha, and you use that value. There are lots of amphiprotic molecules that are on both sides, and so you have to make sure you have it on the right side. If you're wondering if something is amphiprotic, one of the ways to check, can you find it on both sides? And it will be there. I think we might have time for the math thing. Everyone good on this? Good, 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 good. No objections? I can go here. Will we have time? Given the Ka and Kb an initial concentration, calculate the concentration of H3O+, OH-, pH, and POH. We now have a lot of formula. We know quite a bit at this point. So just a reminder, you have Kw because Ka times Kb. Ka is H plus times A minus over HA. Kb is OH minus HA over A. And we have this diagram. When we go back and forth, what relates those two together?
K plus KB.
Ka times Kb is the one we just did. That doesn't relate OH minus and H3O plus. You're close. It has Kw equals, but
W equals H plus
H times OH. So we've done that. If we want to take H3O plus and we want to calculate the pH, what formula do we do? Negative log H plus equals pH. If we want to go from pH to H3O plus, we do
Wait, isn't this the
10
same?
to the minus
as-
pH. Pardon?
It's the same like thing as the one. from-
Yeah, I'm just reviewing it. Because now we're going to put it all together and do some larger calculations. And if I have POH, what relationship goes us back and forth here? Equals 14 at 25 degrees Celsius, or pKw if you're not at 25 degrees Celsius. And then you have a similar relationship going from here down, negative log concentration of OH minus, going up, 10 to the minus pH. So don't forget, these are from the last unit. We're going to need all of them for this unit. And we've added in all of these. Because now we have Ka and Kb. So we have Ka, Kb, we have pH and POH. Because all of this was just ways to get pH and POH and interchange between H plus and OH minus. And now for my favorite part. Ready? If Ka equals 1.8 times 10 to the minus 5 for CH3COOH.
Yo, can you go back up?
I asked if you were ready.
I said no, you didn't hear me.
Well, then say no louder.
I'll just yell next time.
Are you ready?
No.
No.
Now I'm sad. And very stuffed up due to allergies. I want to find a beet person who knows what's pollinating right now so we can burn all those plants.
Alright, I'm good.
Good.
I'm not.
Thank you, Andrew.
Suck, Andrew.
Shut up.
Next page, let's go.
Shut up.
Josh. Andrew, right. Although I appreciate the entire, I'm done. Let me know when you're ready, Andrew.
When is the JKL test?
Quiz next week, probably Thursday or Friday.
There's no test.
It's a quiz, and so far no one has requested to do the test. But if you're changing your mind, let me know.
When do we do the test?
Like I'll put a test in the test center. If you want it to count as a test, I'll give you a much bigger version.
I think I'm done.
Okay. The return of the ice table. If the Ka is 1.8 times 10 to the minus 5 for CH3OOH, what is the pH of a 0.5 molar solution? Write the equation across the top. Balance. We're going to solve. Couple of things. This amount, well, if you have a weak acid, is that the initial or the equilibrium amount? Initial. That's, you just made up the total one. If you measure the pH, is that the initial or the equilibrium? Equilibrium. So we want the equilibrium amount. So it says what is the pH? So we're going to have to calculate what the equilibrium is. And that is the initial of the HA. Write the equation. It's going to be awesome. I wish I had the TV in here so I could dance while I show it to you. For the chemical equation, Ella, what is the formula of acetic acid?
CH3COOH.
Okay, now what does it do?
And then goes to I think it's CH3COO and then plus H plus.
Yep. I don't want to be picky about the chart, but there you go. Yes. We know our values. Where does 0.500 molar go?
Initial.
Initial. Skill testing question at the very beginning. What is the amount of acetate in H plus? Why?
Wait, just kidding, it's 0.
It's 0. Why is it 0?
Because you have everything you need.
You have everything here, yeah. Nothing's happened yet. So, very beginning, you've just got the acetate, it's 0.5 molar. At the beginning, we have 0 molar of both. When I played the music, when we did this, and we did the ice tables, and then we perfect. Now I'm going to ask someone else. What do we put in for our values under change? Andrew Kim, you have been chosen.
Negative X.
Under?
CH 3COOH.
Lovely. Then,
And then it's going to be x plus x, and then it's going to be another plus x.
how'd you know this side was negative?
Because that side has the 0.500.
Makes sense. So then, algebraically, what goes here?
The same ratios, or just x?
Oh, not just that. What goes?
Oh, like
Minus x goes to
0.5 minus x.
0.5 molar. I'm going to take out the sig figs to make it easy. 0 plus x is
X.
0 plus x is x. So we got 0. Now, we know the Ka. Gave it to you. You don't even have to look it up. How nice am I? You just go Ka equals, and write out the whole equation. Like, write this out. Because if nothing else, if you just start putting numbers into it right away, I don't know if you know how to do this. And you made a mistake, or your mistake was because you don't know how to do it. But if you write this out in all of its glory, then I can go, oh, they can write a Ka equation. That's a skill they have, a proficiency they know. I don't have to worry about anything else. And then you can fill in the values. What is Ka?
X squared.
X what?
X squared divided by.
Oh, it's 1.8. Oh, I see. You're doing the other thing. 1.8 times 10 to the, what does it say up top? Negative 12? Negative 5. And then, Katie, what is up here?
X squared divided by 0.5 minus x.
There we go. And you may be thinking, Mr. Neufeld, you said I would never have to solve a quadratic in Chemistry 12. I even have a sound effect for this. If it works. Awesomeness approaches. Watch this. How can we solve this without solving for the quadratic? Yes?
I think you multiply 0.5 minus x out.
Oh, you could. Oh my God, yeah, you'd go one, but you are now solving for the quadratic.
Oh.
You got that, and then you got 0.5 molar minus x equals x squared, and then that's gonna have to multiply into both of those, and then you're gonna get x squared minus some, or plus some amount of x, and like, oh God, it's gonna be a whole thing. And that's for people in AP, and they suck.
Yes, I'm at the AP level.
Take the square root.
Pardon?
Take the square root.
You could take the square root of both sides, but if you take the square root of both sides, that's fine, but then you have x over, like, the square root of 0.5 molar minus x.
You can
cancel
multiply
one of
that
the
first,
Yeah.
and then take the square root.
You can't cancel, can you cancel x over 0.5 minus x the square root of? No, you can't do that. What crazy algebra are you learning in your class? That's not a thing. That's weird. Even your math teacher would be horrified. Oh, I erased the whole thing. Crap. I got two. Hold it. I can bring it back. There we go. So, yeah, we can't do that. That's algebraically not allowed. And the problem is, you're thinking in math, and math isn't real. But we're dealing with numbers that amounts that actually exist in the real world. And numbers, like people, some of them don't matter. All you need, there's a magic phrase. You go, let 0.500 molar minus x equal 0.500 molar.
Oh, you stood up.
Yeah, but then you're gonna have to like solve it this.
Yeah. I just erased the x.
If you just made it like a.
Yeah. So now, can you solve that?
You don't have your skill, Mr. Nichols.
It is a lot of skill. I know.
What?
I don't know just like erase
Yeah.
it.
Woo!
You just erase the X.
I don't like this, so let it not exist. And now it doesn't
It
exist.
was still there.
No, it's not. I told you it doesn't exist.
Go, but like,
I don't like how.
It's just absurd.
What do you mean how? I just did it. I can do what I want. Let's approach it a different way. At what point in the real world, if you had a value and you minused it from it, would it not matter? What kind of x?
0.
0. So if it was 0, it wouldn't matter. Yeah.
You have to make it like A or like a letter.
If it was 11, I think it would be matter. If
No,
then-
a letter.
a letter. Well, no, x is just standing in for a number. So it is a real number. So what could x equal? This is like, think of it this way. You were out taking a photo, I think, yesterday, right? Okay. Imagine we were doing a whole school photo. Everybody, like they've got the crane and they're taking our picture. And someone says, one of the grade 8s is in here. Kirk. Do we take the photo?
Yeah.
Yeah, because Kirk doesn't matter. Who cares? He's a grade 8. Grade 8s aren't real students. They don't really go to arts. They don't go to they just hide away in the bunch somewhere. Who cares what they're doing? Not real students. But if a grade 12 is missing, do we wait?
Maybe.
Yeah, the most important people in the school. Of course we wait for the grade 12. They matter. Right? If x is small enough, Tim, if x is small enough, x doesn't matter. If x is equal to 0.00000001, sig fig wise, what's 0.5 minus 0.00000001? 0.5. If x is small enough, it is below the error of that, and you can just ignore it.
How do you know it's small?
In Chemistry 12, anytime you're faced with this, it will always be small enough. In university in second year, I think, they teach you how to calculate. You can calculate, is it small enough? It has to be within a certain percentage. So if it's like below 5%, you're allowed to make that assumption. And what you do is you do it, you get your result, and then you put it back in and check if it's 5% or more. If it's less than 5%, you're done. And even then, if it's greater than 5%, then you just go, oh, I'm going to use the value, put it back in, and you can reiterate that, or you could use calculus and do it directly.
Can you
Yeah.
still teach us the cubic way though? So
No, because we're not going to do that. Why would we do that? We can do this. Let's pretend that x is stupid. And it goes away. It's not completely gone. And we let it, a small number divided by 0.5 squared is still going to change what that number is. We keep it where it matters. We're not going to expel the grade 8s. We just don't care about them. We still want their tuition. They're still there.
Okay, but don't we still have to solve for x? So
We still have to solve for x. But now we just take that, multiply it over, and take the square root. It's like the easiest calculation in the world.
Alright.
Yeah. You sound a little scared. I want you all to show your math teachers this. They'll really appreciate it.
There is no charge for awesomeness.
Huh? Awesome. I think, made Ms. Walensky a little depressed. Because how many of you are in calculus? You know how you calculate the area under a curve? And this is really important in chemistry because you will put something in an NMR, which is an MRI for molecules, and you'll get something like this. And the area under that curve will tell you how many hydrogen molecules are in there. The pattern of the curve tells you how they're joined together. You get a lot of chemical information. So you think that you would want the area under the curve. You get the equation, use calculus, calculate the area, right? No. What we do is we take a square of graph paper and then we weigh it with a microbalance and we get 1.782 grams. And then we take a pair of scissors and we cut this out Let's say that's 5 by 5. And we weigh that, and that comes out to 0.832 grams. And then we just go 0.832 grams over 1.782 grams is equal to x over 25 centimeters cubed. And then you solve for x, and you know the area. You don't even need calculus. It's a completely useless area of math if you have practical equipment. And I have the answer to 3 sig figs. Beautiful. I heard the heaviest sigh ever from Ms. Malinsky when I explained that. And that's what our entire department did at UVic. It was way easier than trying to calculate some stupid formula. You can just make numbers go away. If you think this is weird, I was doing honors first year physics. We were on a really difficult problem, and we found out we needed to get it down to 1 variable, and we had 2. And we're like, we don't have both. This is an unsolvable. And the professor says, oh, yeah, you don't have that. And it's actually impossible for you to have that. So just use E. You know the mathematical E?
Yeah.
And we're like, why? Like, it's not E. And he goes, yeah, but E is a small number. And that number's a small number, so it'll just work. We're like, are they related? He's like, no. And then you just substitute it in, and it really did work. Most of science is pasted together with duct tape, and people just do stuff that works half the time. So, solve for x. Paste it back in. Get the pH. Go, go, go. I'll make it your ticket out the door. Show me the pH and you can leave.
What if I do it
Yeah.
on my phone?
No, definitely not. Take your phone then. So for x, calculate the pH. I just need to see the number.
3 times 10 to the negative 3.
The pH.
Oh, crap.
Right, and don't yell it out. Just show it to me on your way up. And Dice also says don't yell it out.
What's that?
Well, that has like no sig figs to it. There's 1 sig fig.
3.00.
How did you, what?
Hey, yo, the big
Did you solve? Oh, hold it.
I got
You need more sig figs to that.
How many sig figs?
It's close. I'll
I
give you
got
that.
top duty.
Mr.
Okay,
Dufeld.
what number did you get?
0.5 to
No.
0.9
Yes, you're right.
The 3 sig figs.
Yep.
Square
Go,
root.
come on. I know you can do this
I
in
can
like 2
do
seconds.
it. You know I can
Go,
do
go.
it.
Then do it. Come on, show me. Theo can go.
You go what?
Also, I'm so tempted to do this. Is that a 5?
And the negative 1.
That number right there? You're good.
That's what I got.
Yes. No, hold it. You get not that's what I got. Show me.
I got 2.523.
Show
I
me,
literally
show me.
said it over there.
No. He said it. You just stood here and agreed with that. Good. Okay, you got half to go. Pardon?
2.52.
Good. The rest of you now can go. Please don't pack up your bags before the end of class. It is. It's not bad. And once again, I would like you to all tell your math teachers about this new way you found to solve problems.
This is going to be an unhealthy addiction, just removing math.
You just remove it.
It's like, I don't know how to solve this equation.
This piece is bad. Oh, I'll just get rid of it. Because it doesn't matter.
Just put it aside.
Right. Well, because in the end, it comes back to sig figs. If whatever the problem is less than your error, you can just wipe it away.
Thank you.
You're welcome.